Hello everyone. So today I'm going to show you how to solve a two systems of equation problem using the substitution method. All right, so first, how would you go about doing this? And here's some written rules. So first, you're going to take two variables, x and y, and then you're going to solve one of the equations for x in terms of y. So obviously, when you're doing a two systems of equations problem, there's going to be two equations, and you're basically going to select one of those equations, and you're going to solve in that one equation for x in terms of y. You can also go the other way and do y in terms of x, but for the purpose of this explanation, let's just do x in terms of y. Then you're going to substitute in the result for x in the other equation. This is very important, so that the equation is in terms of one variable, which in this case is y. Then you're just going to solve for y. After getting the answer for y, you're going to substitute in the answer for y in either one of the equations. It doesn't matter. And then you're just going to solve for x. And then after you get both x and y, you're going to represent the final answer as a point on the graph. Because of course, when you're dealing with systems of equations, you're basically dealing with two lines. When we're talking about two systems of equations, that is, you're dealing with two lines, and the solution is basically where the two lines intersect. And so you're going to represent the answer as a point of the intersection between those two lines. So now let's talk about an example of how you would go about solving two systems of equations using the substitution method. So first, you have two equations here, right? You have 3x minus 2y is equal to 6, and you have x plus y is equal to -8. So first, you could take either one of the equations. I'm going to choose x plus y equals -8 because it's easier to solve. And you're going to solve in this equation, you're going to solve for x in terms of y. So this is where I do that. You're going to take x plus y is equal to -8, and then you're going to subtract the y from both sides because it's plus over here. So obviously you're going to subtract, and the plus y, negative y cancel out. And then so on this side, you're going to get -8 minus y. So then you're going to get x equals -8 minus y. Now, what are you going to do with this solution that you just got with x equals to -8 minus y? Well, you're going to substitute it into the original, into the other equation. So -8 minus y, you're going to substitute in for x over here in the other equation. Um, And this is where I do that. So in the other equation, which is 3x minus 2y is equal to 6, you're going to substitute for x, -8 minus y, which was the solution we got in the previous slide. So then what you had to do is you have to obviously distribute the 3 onto the -8 and minus y. So you're going to distribute. So then you're going to get 3 times -8, which is -24. And you're going to get 3 times -y, which is -3y. And then you obviously have to combine like terms, which is -3 and -2y are like terms. So you combine these, and when you combine them, you get -5 over here, and then -24 over here. So then you get -24 minus 5y is equal to 6. Then obviously we want to isolate the y. So you had to add 24 to both sides. So this is how you're going to do that. You're going to add 24 to the left side, which is just going to cancel out. And then you're going to add 24 consequently to this side. And so you're going to get 6 plus 24. Now that is going to be equal to 30. Then you're just left with -5 on the left side, which is going to be equal to 30. And so you're going to have to divide by -5 on this side in order to isolate the y. So you can get y equals 30 divided by -5, which is going to be equal to -6. So that's your final answer for y. Y is going to be equal to -6. And now, if anyone remembers the next step, you're basically going to substitute that -6 into either one of the equations to get the solution for x. So then we go to the next slide. In the other equation, you could also use the one that we just did, but in this case, I'm just going to do x plus y equals -8. You're going to substitute in that -6 that we just solved for y, and you're going to get x minus 6 equals -8. And so then you're going to get x is equal to -8 plus 6, because obviously we want to isolate the x. So for that, you had to add 6 to both sides. So you're going to get -8 plus 6. And so that's going to give you x is equal to -2. And so that is going to be your answer for x and y. X is -2 and y is -6. So this is your final answer. Now, in order to confirm that we got the correct answer, we have to check our answer. And how do we check? Well, we substitute in the values for x and y into both of our equations to see if they match the answer. So the first equation was 3x minus 2y. And so in that, for x, you're going to substitute in -2. For y, you're going to substitute in -6 as we solved for. And so 3 times -2 is going to be -6. -2 times -6 is going to be plus 12. So -6 plus 12 is going to be 6. And that's going to be equal to 6. So it works for that equation. And then you're going to check the other one. X plus y equals -8. X is -2 as we discerned, and y is -6 as we discerned. So -2 plus -6 is going to get you -8. And so both of these equations work for our answers, and so that means our answers were correct. Now let's move on to the next example. So in the next example, we have two equations, 5x plus 2y equals 7, and then 10x plus 4y equals -3. And so these are the two equations. Now you're going to choose one of the equations to work with. So I'm going to choose 5x plus 2y equals 7 because it's easier, it's simpler. And then I'm going to solve for x in terms of y for this equation. So you're going to get 5x plus 2y equals -8. Now, in order to isolate the x, which is what we want to do, you obviously had to subtract by 2y on both sides. On this side, on the left side, that is, it cancels out. And on the right side, it becomes -8 minus 2y. So then you get 5x equals -8 minus 2y. But then to isolate the x alone, you obviously have to divide by 5. And so since it's -2y, you're going to do -2y divided by 5, so -2/5 y, and it's -8, so -8 divided by 5. So you're going to get -8/5 minus 2/5 y. All right, now let's go to the next slide to see how this is going to work. Now, remember, you have to choose the other equation to substitute in your values for. So you're going to do 10x plus 4y equals -3 because, as we remember, that was the previous equation. You're going to substitute in the value for x that we got, which was -8 fifths minus 2/5 y. And then you're going to obviously distribute the 10 to both terms, which is going to get you -16 because when you do 10, well, let me just do it on the side. So when you do 10 times -8 fifths, the 5 cancels out, so you get 1 over here. The 10 cancels out, so you get 2 over here. So then you just do -2 times 2 times -8. So then you're just going to get -16 over here. And the same thing, 10 times -2 fifths. Let's just do that quickly over here. 10 times -2 fifths. Obviously the 5 cancels out to 1, and then the 10 cancels out to 2. So then you get -2 times 2, which is going to get you -4, as we see over here. Now the -4y, obviously now you have to combine like terms, right? So the -4y and the +4y, which is just there, obviously they cancel out. And so you get -16. So you're left with -16 equals 3. Does -16 equal 3? Well, no, it does not. So that means the equation is not true. And so there is no solution to the systems of equation. And so what does that mean? Because obviously when you talk about systems of equations, you're talking about two lines. So what does that mean in the graphical context? Well, in the graphical context, what that means, a no solution essentially means that the lines are parallel. Because if you think about it, parallel lines, well, they never ever intersect. And so that's going to be your final answer, no solution, because the lines are parallel to one another. And so that was my video. Thank you for watching. You guys today learned how to solve two systems of equations using the substitution method. So thank you for watching and have a great day.